Hello and welcome to Jupyter Academy. Today I'll be talking about central limit theorem, which pretty much states that the distribution of the sample means, or the averages of a large number of samples from any population will be approximately normally distributed. So what does it mean? Pretty much it means that if we have a lot of random numbers, then if we plot them like with matplotlib, we would see this bell curve, which is like, wow, what's happening? If we plot their means of a sample, so I'll repeat it once more so you follow with me. We have to see that the distribution of the sample means of a large number of samples from the population will be normally distributed. So this sounds interesting. Let's take a look how we are going to prove it pretty much. So with matplotlib and with Jupyter Lab, we would start with importing some things that we are going to use: random, plotly, express, spx, and then import matplotlib pyplot as plot. We press shift and enter and everything is ready and loading. Okay, we have two variables here that we're going to play with. Sample size would be 31. This is like a magic number. Above 31, people say that it will work. And the sample count would be 10,000. I'm putting underscore so it's visible that it's 10,000. And then let's take a look at the random values that we are going to generate. Just to have an idea how we're going to do it, it would be like this: random.uniform, and then we're going to start with 314 to 42 for underscore in range sample size, and something of course wasn't ready. We are expecting a list, so this is how it should be. Okay, and then the random values are like this. We can sort them, and after sorting them we can see immediately that these are our random values. Okay, sorted, they indeed look random, I mean, no doubt about it. Yeah, let's display how they are scattered. Okay, scatter x values. This is just a function that I'm going to use later. Plot figure size equals, okay, 10 to 6, something like that. And then plot scatter x 1 times len of x, and the alpha equals 0.3. This is for seeing through, so to say. Yeah, better visibility. Plot white x will be like this. And then labels, should I put labels? I will not put labels. So just to see how the scattered egg values are looking like, yeah, you see they are really random. That's pretty much expected. Okay, I want to put actually labels, at least a title. It would be something like scatter plot of len out of x values. Yeah, get a plot of 31 values. Great, works. You see, it really is random, and there is no way that we see a bell curve See, like here we have a lot, here we have a lot, but this is not a bell curve. This is not a standard distribution. But if we make a mean out of this and we do it like 10,000 times, then this should follow this beauty here, which is interesting because for this one the mean is here. Let's see where the mean is. Random values, mean. Okay, random values, average. Okay, actually I'm just thinking that I'm still coding in another language. Import statistics, and then should be something like statistics mean dot mean random values average. So yeah, we have 23, which is okay, I guess. And now we have 22. But you see that we don't have a bell curve. And the idea is that if we do this a lot of times, then the means should display the bell curve. Let's stop explaining and continue with showing it. Generate sample average, something like this. This would be a function accepting the sample size and returning just the sum, random uniform between 314. I just selected 314 randomly because it's pi and 42. So this is what our values would be, our random values. You see, the first one is from 314 and the last one is around 42 here. Okay, for underscore in range sample size divided by sample size. And let's try this one, generate, and then we have the sample size, which was how much? Pretty much 31. Okay, fair enough. And now we want like this function here to be called 10,000 times. Let's see what will happen. We'll call it x values, and our x values would be generate sample average, sample size, for underscore in range sample count, and let's see how the x values look. Yeah, they look nice. So what we are going to try to prove is that these values here, if we plot them, they would be in a curve, in a bell curve with standard distribution. So what else do we need? We need y values, but they're going to be like this, quite easy, times sample count. Yeah, nothing fancy here. Pressing to this and deleting it. And now let's scatter the x values pretty much just to see how it looks like. This one, well, we see something that most probably is a bell curve, but it's better if we display it with a histogram because we don't see any difference between here, and there should be difference in the histogram. It should be visible. So let's give it a try. So x equals x values, y equals y values. How many bins should we put? 50, for example, and then let's show. Of course, what is not, okay, y is not defined. Yeah, because of the point. and we see a bell curve with 50. If we put like 30 bins, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so to 30, we see a bell curve. But for the bins, if we put 0 bins, means displaying all the values as they are, well, yeah, this is what we call a bell curve. It looks like a bell curve, so most probably it is a bell curve. This is because we have a sample size here of 31. We put a sample size of 1. Let's see what will happen. Generating everything again. So it means that we're just displaying our values because we don't have any average. See, it simply looks like quite okay a way to go with passing the test. This is really random. What will happen with 2? 2 is already should be something, well, that's not a bell curve, definitely. So the magic number is 31. At least people say it is so in a lot of examples, or over 30. And this is how the thing looks like. So pretty much that's all. Thank you for watching. Let me know whether you like this one and you learned something new, or at least you get motivated to read about the central limit theorem. And that's all. Enjoy the rest of your day or night and take care of yourself. Bye bye.